All right, so 6.5, number 13. So the setup of it was really similar to numbers 11 and 12, okay? And I set those problems up to be similar for a reason. I wanted you to kind of see the different types of problems that you can have to work with. All right, so in 13, if you're working in the back, that's cool, but voices down, please. All right, so 13, it says you push a 54-kilogram object with a force of 143 newtons, a distance of 13 meters across the floor. So draw it. Here's the floor, here's the box, it's got a mass of 54 kilograms. You're pushing it from rest. Oh, I guess it doesn't explicitly say that in 13. It said it explicitly in 11 and 12. Shoot. That is a problem. Is that what messed you up, Milena? That you didn't know the initial velocity? Or did you assume it was 0? Okay, good. Yeah, all right. So I need to fix that, though. But yeah, you were supposed to assume it started at 0. Is everybody cool with that? All right. And so then there's the force of U, which is 143 newtons. You're going to push it through a displacement of 13 meters. And at the end of those 13 meters, it tells you it hits a velocity of 2 meters a second. All right. So notice, you guys, my setup here is exactly the same as what I did before. I identified the important points in the object's motion, and now I'm going to think about what I know about the energy at each of those points. Okay? So let's call this point 1, and let's call this point 2. So, Milena, if you don't mind, I'm going to pick on you.
Yeah.
So point 1, talk to me about the energy.
So all you have is gravitational potential energy.
Okay. What would the height be if I was going to...
0.
Oh, okay. Yeah.
Yeah, so it'd be 0.
So-
0 there. And then on the second one, the GP is 0.
All right, hold tight for 1 second. I just got to catch up to you. All right, so is everybody good with that at point 1? There's no energy, right? No velocity, no height, no KE, no GPE. Everything's good. Yes? Everybody happy? Okay, over here at point 2, so go ahead now.
So the GP is 0 as well, but you can find the kinetic.
Yeah, you can find the kinetic energy, right? Just do 1/2 mv squared, right? And I think you get 108 joules, if I remember right.
Yeah.
Oh, so that means that my total energy is 108 joules. All right, so is everybody good up to there?
What's that for?
I don't even know. I think it asks for the coefficient of friction. All right, and I said I don't even know a little bit tongue-in-cheek, but my point is you can kind of just read through the given information and sort of go on to autopilot for a minute, where you identify the important points and evaluate the energy. Okay, and then once you've done that as much as you can, then go back and read the question and see what it's asking you. Because this is how every one of these problems starts. Follow? All right, so is everybody good up to here? All right, so to Alex's point, the problem wants us to know the coefficient of friction. What kind of friction, you guys? Kinetic, right? So I think I'm going to have to use this guy to find the coefficient, right? So we can find our normal force relatively easily, right? Because it's just going to equal our force of gravity, right? Okay, so our force of gravity is equal to our normal force. That's 500 and, what is it, 20?
529.2.
29.2, thank you. Everybody good with that? Okay. Go, brain, process. All right. So now the only other thing that I need is, if I'm trying to find my coefficient, I need to know my force of friction, right? Everybody good? All right. So I'm kind of stuck. So when I get stuck, I'm going to go to these guys. What do I know about the total energy? Is it constant or changing? Changing, so I should do what? Find the work of non-conservative forces, right? So which equation should I use? The top one or the bottom one? Bottom one, right? Cool? All right, well, let's do that then. Let's see. So that means that the work done by non-conservative forces is this? Oh, it's just going to be 108 joules, right? 108 minus 0. All right, so at this point, there are two paths we can go down. Because now it's this. We can either think about it in terms of the sum of the two works, or we can think about it in terms of our non-conservative force total. So how you do it, I guess, is kind of up to you. So here's what I know. I know that the work done by non-conservative forces is 108 joules. So Milena, since you specifically asked about this one, do you have what is sort of your intuition? Like, where do you want to go with this? Or are you totally stuck?
Going to put that in the first equation and find.
Yeah, I think that'll work.
Go into find.
Okay, so good. So the question is, so when you plug this into the first equation, so let's see, we know our non-conservative work, we know our displacement.
No, we know his force.
So, okay, but so here's where you got to be careful. There are two non-conservative forces. There's Roy and friction. Okay? This is the sum of those two things. Right? Because these are the two non-conservative forces, and this means the total of them. Does that make sense, Milena?
Yeah.
Everybody, does that make sense? Okay, so let's go down that path then. Let's solve this. So if we do work of non-conservative forces is non-conservative force times displacement, then I get 108 equals whatever my non-conservative force is times my displacement of 13 meters, right? Follow? So divide both sides by 13, and you get that your non-conservative force is whatever 108 divided by 13 is. Everybody have that handy? You got it, Lauren?
8.31.
8.31. Thank you very much. Newtons. So the idea is this is the combined effect of all of my non-conservative forces. Make sense? Oh, well, but I know Roy's force. So that means that here, let me write it out again. This is probably redundant, but so this is this plus this, right? So that means my total force is 8.31. Roy's force is 143 plus the force of friction. Good? So subtract the 143, and your force of friction ends up being, what's that going to give you, 134.69 or something?
Yep.
Is that right? It is negative, thank you. Follow? All right, and now we can find our coefficient, right? So now you just do and solve for your coefficient. And you get, is it 0.25?
Yeah.
Did it? Good. Elena, good?
Yeah, I made a mistake. I kind of didn't split the two.
To separate the two forces, you just accounted for one of them. Gotcha.
I get it.
Everybody good? All right, 12 is similar to this, kind of the same idea. There's two non-conservative forces. So if you struggle with 13 and 12, maybe go back and try 12 again and holler at me if you can't get it. All right? Cool.